Assalamu alaikum. I think it is going to be more effective to be discussing with you through videos. I will be making videos and I will be sending them to you. You watch the video. If you have any question, you will let me know. I will be sending assessment and assignment through the videos. We communicate through WhatsApp and any other means. So it will be faster, and then I will have enough time to make enough video and send them to you. So this is going to be the first video series. I've tried to make some videos yesterday, but I did not have quiet time. All my children, they are disturbing, so now they are sleeping. So that's why I just want to make this video now. So as you see, we're going to discuss chemical calculations. We'll talk about all the aspects of chemical calculations. I have some learning outcomes here that if you are able to cover them, that is what I'll be following actually. So I should be able to measure what we are doing through the learning outcome. So the first one is when you finish this class, we should be able to explain the carbon 12 atom is taken as the standard for working out masses of other atoms. Another one is to be able to express the meaning of the symbol AR and MR, and then to be able to calculate the values of MR if the value of AR is given. And then you should be able to explain the difference between the relative formula mass and relative molecular mass. And finally, you should be able to explain that the AR value of an element is the average value for all its isotopes. So let's get started. So the first thing under this learning outcome is to be able to calculate relative atomic mass. So that is the reason here, relative atomic mass. So why and what is relative atomic mass of an element? So if you have an atom hardly weighs anything. It doesn't have a mass, or if it has a mass, the mass is so very small. So you cannot use normal scale to weigh an atom. But scientists, they need to know, to find a way to compare the masses of atoms. If they cannot weigh them, then they should be able to compare them. So what do they do? The first thing they do, or they did, is that they choose an atom of carbon-12 to be the standard. They choose carbon-12 atom as the standard. Because they could not weigh atoms, so they need to compare atoms. So if you want to compare anything, you should have a standard that you will use to compare other things. So the standard that they choose when they wanted to compare atoms was carbon-12. So when they choose carbon-12 as the standard, they fix the mass of carbon-12 as exactly 12 atomic mass units. So that's the next thing they do. They fix the mass of carbon-12 as exactly 12. Atomic mass units, AMU. So the first thing they did, the reason why they did that is because carbon-12 the reason why they fixed the mass of carbon-12 is because it has 6 protons and 6 neutrons. And then remember that protons plus neutron is the mass number of an atom. So that is why they took the second step, because it has exact 6 protons and 6 neutrons. The mass of electron, they ignore it, actually, because it has 6 electrons as well, but the electron is very, very negligible in mass. So after that, they compared all other atoms. They compared it to this chosen atom. So they compared all the atoms to within this standard atom. So the first thing that they took carbon-12 as a standard, they fixed its mass, and then they compared all other atoms to the standard atom. So what did they do the comparison? Because it's not that they put it on the table and that they are comparing. They use a machine that we call mass spectrometer. Mass spectrometer. So that is the machine that they use for the comparison. So when they did that, they got the mass of all that. For example, you know that carbon-12 is written this way. See, 12 and 6. 12 on top here stands for the atomic mass or mass number, and then the 6 stands for the proton numbers. So carbon-12 has 12 mass number and the proton number 6. So now, if they want to measure the mass of magnesium, they compare it to this. It is like you are comparing on a scale. So let me use this on a balance, just for us to understand what happened. Let me just draw one side of the balance quickly. So I'll draw a side of just like an illustration. So they put carbon-12 on this side, and then they put magnesium atom, for example, at this side, Mg. You know that carbon-12 weighs 12 grams. So for magnesium atom, when they put it, this part went up. So it means magnesium is bigger than carbon-12 atom. So what they do, they have to get another carbon-12 atom to do that. So when they did carbon-12 atom, when they put another carbon-12 atoms, the scale becomes balanced. So when it becomes balanced, it means one atom of magnesium weighs the same as 2 atoms of carbon. So with that, it means magnesium weighs 24 grams. So that is how they did the comparison for all other atoms. For example, like hydrogen, when they put hydrogen at this side, when they put an hydrogen atom at this side, this one still goes down. They put another hydrogen atom, it still goes down until they put up to 12 hydrogen atoms. So when they put 12 hydrogen atoms, the scale becomes balanced. So in that case, we know that we need 12 hydrogen atoms in order to weigh the same as 1 carbon atom. So it means 1 hydrogen weighs 1 gram. So that is how they got atomic mass for hydrogen and for all other atoms. So, summary. The Learning Outcome says we should explain how the carbon-12 atom is taken as the standard for working out masses of other atoms. So they took it. The explanation is that they took carbon-12 as the standard. They fixed the mass of carbon-12 because they fixed it as exactly 12 atomic mass units, because carbon-12 has 6 protons and 6 neutrons. And then they compare all other atoms to this standard. using a machine called mass spectrometer. So with that, you got the masses of all the atoms. So with this explanation, you should be able to define we should be able to define relative atomic mass units. So let's try. I will just put the definition down here of the relative atomic mass unit of an element. So based on this, the relative atomic mass of an atom compared with the carbon-12 atom is called the mass of an atom compared to its carbon-12 atom. The mass of an atom compared with the carbon-12 atom is called its relative atomic mass. And then this is the symbol to represent it, AR. So R stands for relative to the mass of carbon-12. So when you see A like this is the mass number of an atom, R means relative to the mass of carbon-12. So as I said, the AR of hydrogen